Okay, in this video we're going to have a look at some of the reactions with different chemicals, not just water, from metals, and also how we use those then to form a reactivity series. Okay, so I'm going to go through the notes here from your book so you can see how this video links in with the work that you will have in front of you. So here's my list of metals that we've got here. You'll notice that within this list we've also got hydrogen, which is not a metal, and we'll come back to why that's in there in a little second. Okay, so the first column here is looking at reactions with water, and the metals at the top are the most reactive metals in this list, working our way down here to gold, which is the least reactive metal in this list. And you can see that the metals at the top, because they are more reactive, these reactions are very violent, very vigorous. We get hydrogen produced with water. We get a metal hydroxide, the alkali formed with water. And you've seen those reactions happening in the video, showing that hydrogen forms. We can do the pop test, and the metal hydroxide is the alkali, as I said, which makes the indicator turns purple. And as you come down the list, then we move into this category of metals in the middle of the table, where they will react and they will produce hydrogen, but very, very slowly. Nothing like as violent or as vigorous as these ones will do here. So they start to get a slower reaction here. Think about iron. Iron will react with water outside. Objects that are made from iron will react with water very slowly. Nothing like a piece of sodium, which is a very vigorous reaction when it's dropped into water. And at the very bottom here, these reactions here do not, so these metals here do not react with water. Think about it common sense wise. Lots of pipes that carry water around your homes are made from copper. It wouldn't make no use at all if that copper reacted. And then we've got silver and gold. Think about the Queen washing her dishes. She puts her hands into the water with all the jewellery there. The jewellery doesn't suddenly react and disappear. It's unreactive. Okay, so these bottom ones are unreactive. It's probably worth explaining at this point. This is why hydrogen is here, because water contains hydrogen, and what we're asking the metal to do is to react with the water, displace the hydrogen, and if their metals are below hydrogen, then they can't do that. So anything that's below hydrogen reactivities will not react with water, and that's why hydrogen is listed. Next column, we've got acids. Okay, again, same kind of pattern. The ones at the top of the reactivity series are very vigorous, very violent. They all react to release hydrogen gas, and they make a metal salt. But as you come down, the reaction gets less vigorous, less violent. This middle section here, you can see it's quite a slow reaction. And then again, those below hydrogen will not react at all. Think about why. Acids all contain hydrogen. HCl is hydrochloric acid, nitric acid, HNO3, H2SO4 is sulfuric acid. They all contain hydrogen. Metals below hydrogen reactivities cannot react with these acids because of that reason. Okay, so we've got the patterns here in the reactivity series, and we can see how it links to reactions with water and acids. We also need to be aware that when metals are more reactive, they are more likely to form cations. Okay, what that means, if I pick on sodium, sodium is 11 electrons, 281 is the arrangement. This is not stable. What it wants to do is lose that electron to form a sodium ion with the electron configuration of 2,8. That is now stable. Because sodium is very reactive, it's really good at doing this. Okay, so these metals at the top, where they are more reactive, are good at forming cations, positive ions, whereas you come down, they're not as good at forming cations. And that's the same with this next column, because the ability to lose this electron, remember oxidation is loss, so this is an oxidation reaction. It's been oxidized. So the ability to form cations and the ability to oxidize those electrons is, those two are linked to each other. Okay, you should be able to fill this table in as we've just done, and underneath here are some questions that you should be able to answer on the basis of this table. There's going to be a second part of the video which then looks at reactions with acids in particular. Okay, good luck with that work.